All right, so we have now studied linear and exponential functions. These functions were relatively simple because they were always either increasing or decreasing for their entire domain, so all of the x-axis. We now will start to study other functions, most notably quadratic functions. So quadratic function, we've done some work with this about putting things in ascending order or descending order. A quadratic function, the standard form, is y equals ax squared plus bx plus c, where a cannot equal 0, but b and c can be equal to 0. So read the definition above for quadratic functions and answer the following questions. So why is it important for the leading coefficient to be non-zero? It's important because if it was 0, then you would just have another linear function. So it would be linear if a equaled 0. So we're going to look at some that are quadratic functions. This one is quadratic because of the x squared. This one is quadratic because of the x squared. But then you look at these two. This one is not quadratic because it has an x to the third, and this one is not quadratic because it has a square root inside it. So look at this function, write it in standard form, and state the value of the leading coefficient. So we're going to put it in descending order. So y equals negative 3x squared, let's go with the largest x squared, plus 7x plus 10. So the value of the leading coefficient is negative 3. So if we have a function, f of x, and we want to find, without using the calculator, the value of f of negative 2. So we're going to do 2 times negative 2 squared minus 3 times negative 2 plus 1. So just because it's a quadratic function doesn't mean that you're going to do anything different than you did if it was a linear function. You will still plug whatever that number is in for x. So this will be 2 times positive 4, because negative 2 times negative 2 is positive 4. Negative 3 times negative 2 is positive 6, plus 1. 2 times 4 is 8, plus 6, plus 1 is 15. So they still behave in similar ways to other functions. So if you put an input in, you will always have an output. But they start to behave differently from linear and exponential functions because sometimes the outputs will repeat, but it will still be a function. It will still pass the vertical line test. So we're going to square negative 3 and get positive 9. We're going to square negative 2 and get positive 4. Square negative 1 and you get 1. 0 to any power is 0. 1 squared is 1, 2 squared is 4, 3 squared is 9. So let's graph this function. When x is negative 3, y is 9. When x is negative 2, y is 4. When x is negative 1, y is 1. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. So you will see that you created a symmetrical equation. The range is the y values. And we're looking at this range. It never goes below 0. So y is always more than or equal to 0. Another way you could write this is that the range, 0 is as small as it goes, but it can be infinitely higher. So either one of these are an appropriate way to write range. So let's look at this next function. We're going to use our calculator to help generate a table, and then we're going to graph this parabola on the grid given. Show the table of values that you use to create the plot. So we're going to use decimals to do this. So I plugged in the equation, and then I tapped the little gear button above the equation and tapped the table. So now I have a table. So our table that we're going to use, when x is negative 2, y is 0. When x is negative 1, y is negative 5. When x is 0, y is negative 8. When x is 1, y is negative 9. And when x is 2, y is negative 8. I would typically try to find as many as I can to show a symmetry. But this one, it automatically goes from negative 2 through 2. And we can graph this as is. So when x is negative 2, y is 0. When x is negative 1, y is negative 5. When x is 0, y is negative 8. When x is 1, y is negative 9. And then when x is 2, y is negative 8. And you'll see that we can actually create our own symmetry from here. So we now have this graph. I'm going to move this off the screen. So we're going to look at this range. The range is y. How far down does y go? Y does not go any further than negative 9. Remember, you could always write this as negative 9 to infinity. Over what domain interval is it increasing? Well, if you look at it, when x is 1, and then we go to the right, it's going to keep increasing from that point. So, x is increasing from 1, or 1 to infinity. So state the coordinates of the parabola's turning point, so the vertex. The vertex is right here, where it turns, and that's when x is 1, y is negative 9. Now the axis of symmetry is where it ends up being the line that mirrors. And that axis of symmetry, that equation is when x equals 1. And then what are the x-intercepts? Well, the x-intercepts are also called the zeros, the function zeros. It's the point where the graph crosses the x-axis. So the graph is crossing the x-axis at negative 2, 0, and again at 1, 2, 3, 4, 0. This makes sense because it's when y equals 0. The last thing we're going to look at is the quadratic function of f of x. It has selected values shown in this table. So what are the coordinates of the turning point? So we're going to look and see where it starts to have a pattern. Well, you'll see that at 2, 13, on either side of it, it goes 12, 12, 9, 9, and then 4, 4. So that means that the turning point has to be at 2, 13. And then the range, you'll also notice that it looks like 13 is as high as it gets. So y will always be below 13, or it's going to be negative infinity, and 13 is as big as it's going to get.